Hi, welcome to my channel Techie Talks. I am Anand Gaurav, a cybersecurity professional with more than 13 years of working experience in IT industry, and I'm super excited that you are here. So in this channel I'll be talking about the latest emerging technologies in the area of quantum computing, cloud computing, artificial intelligence, blockchains, and many more. So whether you are a beginner or an experienced tech enthusiast, I'll simplify the complex concepts into clear, easy to follow lessons that anyone can understand. Well, in today's video, which is actually my first video, I'm going to talk about quantum computing fundamentals. So let's get started. And I really request you to please like, share, and subscribe this channel so that anytime I upload a new video, you get notified. And this will also motivate me in making some new videos in the latest technologies, right? So today agenda is to understand the building blocks of the quantum computing. So before we understand the basic concepts of quantum computing, let's first know what does quantum computing means, right? So quantum computing is a new kind of computing uh, emerging in the area of IT industry, and it is basically fundamentally derived from quantum physics, okay, which says about how the particles behave at the atomic and the subatomic level, right? So say for example light. So light has the dual nature. It can behave like both a wave and a particle, say photons, right? Unlike the classical computers that we use right now, that has binary bits, which 0 and 1s, the quantum computers use qubits, okay. So now let's understand what are the some basics concepts involved in quantum computing. So qubits. So basically qubit is opposite, I would say, to the classical computers that use right now. So unlike classical computers that has a fixed 0 or 1, the qubits lies between 0 and 1s, right? So it can exist in both states simultaneously, okay. So an object in the quantum computing can have both 0 or 1, okay, and that's called as superpositions, okay. So this property of quantum computing, it allows the quantum computers to represent and process the complex information more efficiently than the classical ones, because it's not defined, right? You cannot specify whether it is 0 or 1. So it can be anything between 0 and 1, right? So next comes the concepts called superposition. So as I said, the qubit can be in a combination of 0 and 1 at the same time, right? So it basically helps the quantum computers to do parallel computing, okay, and it helps the quantum computers to do complex calculations, right? And think it like a, if you are spinning a coin in the air, right? So when you spin a coin, it's not just head or tails. It can be in anything in between heads or tails. So it's a blend of both, right? So you cannot determine whether it's a head or tail if it is in the air, okay. So that is called a superposition. It can be anything. Then we have a concept called entanglement. So it is basically the concepts where the qubits can become correlated, right? So if one state of a qubit can affect the state of the another qubit, even if they are at a distance, okay. So if one qubit is at 0 state, okay, it can influence the other qubits to become 0, or vice versa. Maybe if it's a 1, then it can affect the other state to be at 1, okay. And this actually helps the quantum computers to process the complex informations, right? The complex calculations. Then we have interference. So here what happens is the quantum computers uses interference, right, to amplify the correct solutions and to cancel the incorrect ones during its computation phases. Okay, so think it like a wave of water. Okay, so the wave of water can add up. Okay, so you can call it as a constructive interface, or it can cancel the each other out. Okay, you can call it as a destructive interference, right? So basically in interference, the quantum computers, uh, it has the ability to amplify it correctness, right? So there comes uh, the capability to solve the complex algorithms, right? The complex calculations through interference, through entanglement, through superpositions. Okay, then we have a term called measurement. Okay, so when you measure a qubit, okay, so at that time it can collapse to either 0 or 1. So what happens it, when you do a measurement, the qubits leave uh, its superposition. Okay, and at that time whatever is there, right, so that is that comes as an output. Okay, and that outcome is probabilistic, right? So based on the qubit state before you did the measurement, right? So think it of like a spinning a coin. So when the coin is spinning in the air, so it's in a blurry state, right? It can be heads or a tails, like a superposition, right? In parallel and simultaneously there could be uh, anything, right? So and once you stop the coin, okay, that is called as a measurement. So what happens is when you stop the coin, it comes out of its superposition phase, and whatever is there at the current state, it is your output. Okay, so whether it could be a head or a tail, so there you decide, okay, so the the outcome is head or a tail, right? That is termed as a measurement. So basically these are the five basic concepts involved in the quantum computing. Okay, I hope this is clear, and if you have any questions or doubts, you can mention it in the comment box, and stay tuned for the next videos to deep dive into the quantum computing, where I'll explain the advantages, the benefits, the drawbacks, and the challenges with the quantum computing. Thank you.